M-1.06 solar flare duo occurred at 019 and 0928 UTC on 11 July 2022 from region 3056, which continues to be very fun to watch. Included with this region, there is still a heightened chance of even an X class, but more notably 3055 to the west of that and 3053 to the north of that both have a much more significant chance of events. Well, actually, they dropped the projection on 3053, which is the one to the north. But looking at these solar flares, we can see the peak events from those two flares right here. And beautiful flare, or beautiful flares. There we go. So in that, post that, we still have a lot of activity that is ongoing. And you'll see from looking at angstroms, 131 angstroms, 131 angstroms, this filter shows us in more clarity where the hottest point flares are occurring with the bright flash, the white light, and to give us a good idea of what is going on. And basically, if you look at region 3056, it's kind of doing a rapid fire succession of flares right now. So this could have a lot to do with its design and structure. And there's even a proton chance, a chance of a proton event from this region. So in all, the projection from NOAA is that there's a 99% chance of a C class, which we can see how clearly that is a strong possibility. We're in C class range at the moment. And there's a 60% chance of an M class, which I do believe, I would even say a 99% chance of that. 20% chance of an X class, which is what I was actually waiting for last night when I saw those two M classes. I thought there was going to be a escalation, which there was not. And then a 20% chance of a proton event, which is mostly wagering in three different regions: 3053, 3055, and 3056. It probably helps if I point to it, huh? 3053 is here, 3055 is here, and 3056. And there we go. So these are the regions we're going to be looking at mostly in this upcoming day and so forth. At the current, 3053 and 3055 are both in the strike zone, as it were. If an event happens, it has the optimal chance of impacting Earth. So if there's a massive CME, the fastest CME recorded is approximately 17 hours. And some can take us up to 4 or 5 days. So we can see an event from there very clearly could be directed directly at Earth. So that's exciting. And additionally, a flare is the light that's emitted, so that's going to hit us when it happens. Well, 8 minutes. It takes approximately 8 minutes for light to travel from the sun to the Earth. And let's take a closer look at the HMIBC and see how these things are getting along. And you can see here, by looking at the HMIBC, this is going to show us where the positive and negative polarity is within those regions, give us a good insight to what to possibly expect. The dark blue, or the darker the blue, the more positive. The darker the red, the more negative. Yellow is light negative and green is light positive. But as you can tell by looking at this, there's a lot of intermingling of those polarities. And that's why we're seeing a lot of flares. The more intermingling there is, the more chance there is for collision of the loops and exchange between the energy to transfer and cause a flare. So whenever you cross wires that are live, you get sparks. And that's more likely to happen the more wires you have that are crossing. And here we have a lot of wires that are crossing. In all, it's a very beautiful thing, but definitely something to pay attention to for satellite operators and things of that nature. We definitely have a high potential right now. Very beautiful, though. And we can see there's very large umbras for these positive regions right here. There's positive sunspots right here, and this trio right here. You got a good negative umbra here, but noticing the negative on 3053 seems to be a little more spread out, as it were, compared to the positive area. And while this one seems to be in 3055 a little more organized, where the strengths are at, that's not going to do a lot for it when you have these mixed polarities going right next to the strong ones. And that's going to cause some issues, and you're going to see some flares from that. And looking at the region that's been giving us a couple of M classes already, 3056 coming around the corner, and you can see how it has the negative, then the positive, then the negative, and that's going to cause a conflict as well, wanting to have more interaction. And then we have this region coming up here soon as well. It's named already as 3057. And I dare say there's probably going to be an increase in projected energy from this one as well, the better we get an analysis of it. Seeing that I can see there's a polarity mix as well here, and it does appear that there's going to probably be some reconfiguration, reconstructuring as it gets its alignment of polarity a little straightened out, as it were. So we'll probably see some events from here as well. And looking at 131 or 171 angstroms. This is the best filter to view for the coronal loops, and in this case situation, it's going to give us a good view of what is happening at these exchanges at some points. So let's go ahead and get this rolling, and we'll see here. Get my little pointer here. This little pointer, once again, is named after Mark Rober, the gentleman that helped design, engineer the Mars rover, the Mars Curiosity rover. Good stuff. All right, and there is this one. You can see the beautiful flash, some reconfiguration. But what I'm looking for is going to be coming from these areas right here. And you can see here there's a lot of activity, a lot of flares, smaller flares, a lot of loop movements. This right here is, it's just biding its time. We're going to get something really nice from here. And noticing also this very beautiful filament coming down right here, showing even on 171 angstroms. We'll look closer at that 304 angstroms, which shows us the plasma a little more clearly. All right, and let's go ahead, and there we go. There we go. There's the M classes right there. And we'll go back to that again. So, looking more carefully at this, we can see that these loops farther reaching, yet this overlapping where you have that positive, negative, positive, it's causing a reconfiguration to be forced as it finds a path of least resistance and reconfigures with the closer loops that can transition its energy. And let's go to 304 angstroms. Light waves at the distance of 304 angstroms between valley to valley with one peak below, or peak to peak with one valley below. And looking at 304 angstroms, we can view a little better those filaments and the plasma movement. Ooh. So let's go ahead and go playback speed, slow you down. There we go. All right, and yeah, I enjoy the science stuff. It's beautiful. And there we go. There's that event that occurred there. But notably, that filament. And let's go ahead and where's my thinking out loud? What can I say? All right. It's still loading. That's why it's so slow. All right, and this will show us as beautiful flares right there. Right there, there's the CME that occurs. There's another one. Now, while we're looking at these M classes, it's good to note that there's actually a lot more activity going on other than these flares. More notably, there's a lot of filament eruptions and a lot of CMEs occurring. So the sun isn't as peaceful as, an event happens and so on and so on. All right, so let's see. We got one that happens on the North Pole right there, little tiny one, but that doesn't go anywhere. And we have one that occurs right there, a little small flare with the CME, and there it is. That's what I was looking for. Beautiful CME with the solar flare right there. We looked at that one earlier. And there's the center one right there. That right there is just a burst. Nice, beautiful, nice, beautiful eruption. Let's get that one again right there. And then that is going to be a CME projected towards Earth right there. That right there, what happened. We'll look at it again. Right there, beautiful, beautiful eruption. That is going to be projected towards Earth. That's a perfect strike zone type of CME. So we'll probably see that impact our magnetosphere. And that happened approximately yesterday, approximately 24 hours ago. But more notably, this is another one I was looking for. I think this is absolutely gorgeous. This filament eruption we were looking at the other day. And here's a beautiful view of it. We get to see it in, here we go. Just incredible. So if you wonder why sometimes you see a lot of activity happening on the sun, but there's not a lot of activity reaching Earth, it's because there is a lot of gravity that it has to fight for that plasma to get away from the sun. So you can get a CME, coronal mass ejection, that barely gets away or doesn't get away at all and just falls back to the sun and becomes plasma rain. And almost all of that, if, well, yeah, not all of it came back, but almost all of that came back in a beautiful display. Now, of course, if there are a lot of loops in a region where it comes back, there's a chance of causing more disruption and things of that nature. But it's also, when those things come back, it has a greater chance of developing another, and as we can see it in time right here, another prominence to form right there. And we can watch it happening as it gets stronger and stronger. Which means we'll probably get one more display before it's out of view. Hopefully. We'll see. Notably, this huge filament right here, keeping an eye on that still. This one is just magnificent. It's been doing a lot of motion, but I think it's pretty well seated. Now, a filament has its seating down into the, oh, yep, there it goes. Yay. Has its seating down into the photosphere. So it goes through the surface down. Oh, and there was a tiny CME I had not seen prior. Right here. There was a little CME that occurred. Let's look at that again. And we're looking at this right here. Right there. Small CME, not anything significant. May not have even really departed the sun much if it did. So I wouldn't really look toward that much. We may get, if it did become an ICME, which an ICME is the next step from a coronal mass ejection, it becomes an interplanetary coronal mass ejection. This means that it's going to travel beyond the orbit of the sun and, well, cross planets. And the final thing of note I wanted to point out, there is a small CME that's happening here, but the main filament does not erupt, so I've been watching that. But right here, another beautiful side-on view, we can see another eruption occur coming up near the tail end of the past 48 hours of observation right there. Now that event that we're seeing is occulted partially, so it's just out of view. The surface of the sun is just out of view, but we can see that had a pretty significant CME to the side. We're not looking at anything from that to even impact Earth, which is nice, because we have plenty coming towards us.